All right, we've looked at what makes a function a one-to-one function. Specifically, each output comes from only one input. And the reason we want to look at one-to-one functions is because these are the types of functions that have inverses. Let me give you the definition of an inverse. So let's let f be a one-to-one function. And let's say its domain is A and the range is B. So it sends x values in A to y values in B. Then its inverse function, which we write like this, f inverse, and I need to tell you right away, this does not mean f to the negative 1 power. I know that when we have variables and numbers, where there's a little number up here, that refers to an exponent. But when we have a function and we put a little negative 1 up here, it is not an exponent. It is notation that means the inverse of that function. So suppose we have a one-to-one function f, then its inverse function, f inverse, has domain B and range A. So the range and domain have swapped, and it's defined by f inverse of y equals x whenever f of x equals y for any y in B. So what that means is if our function f takes the value x and sends it to y, the inverse function takes y and sends it back to f. I know that this notation might be a little bit confusing, so I'm going to do a little bit of a drawing here. If we have a set A, which is the domain of a function, and that function takes things in A and sends them to elements in the range B, then the inverse function basically undoes that. If f takes some quantity x and sends it to y, then f inverse takes y and sends it to x. It's just the function that undoes what the original function did. Now, there's a lot of things that we could say about inverse functions, but I want to focus right now on how to find the inverse of a function. If we're given a function, how we can find its inverse. And we have a short step-by-step method for this. So to find the inverse of a one-to-one function, we start off by writing the function as y equals whatever the function is. We switch the x and the y, we interchange those variables, and then we solve for y in terms of x, and then the resulting equation is our inverse. Let's go ahead and do a few examples. And our first one will be to find the inverse of f of x equals 6x plus 2. Now this first step, write y equals f of x, just means that we're going to write y instead of f of x in the equation. And once we've done that, we can switch our x and y. So we can write this as x equals 6y plus 2. And it might seem weird at first that we're switching the x and the y, but hopefully it's actually a little bit intuitive, because remember that our inverse function switches the input and the output. It switches which is the input and which is the output. So of course, switching the x and y here lines up with that. And then once we've interchanged x and y, the hope is that we can solve for y in terms of x. We can do that here first by subtracting 2 from both sides, giving us x minus 2 equals 6y. And then if we divide both sides by 6, that gets our y alone, x minus 2 all over 6. And so that is our inverse function. F inverse of x equals x minus 2 all over 6. And it should make sense, actually. This is an example I've set up to see kind of clearly how these are inverses. Our original function took x and it multiplied by 6 and then added 2. If we want to kind of undo that, we need to subtract 2 and then divide by 6 to get where we started from. So you can see here how those are inverses. Won't always be as clear. Not every example is quite so clear, where you can see how those steps are undoing each other, but this one was set up to be that way. Let's look at another example. Let's find the inverse of g of x equals x cubed plus 2. Again, we're going to replace our function with y. So y equals x cubed plus 2. And then we're going to interchange x and y. So this will be x equals y cubed plus 2. And then our goal is to solve for y. If we subtract 2 from both sides, that's going to be x minus 2 equals y cubed. And then how do you undo cubing something? You take the cube root. So we're going to take the cube root of both sides. That gives us the cube root of x minus 2 equals y, because taking the cube root of a cube cancels out. And so this is our inverse function, g inverse of x equals the cube root of x minus 2. Let's do one more. This one's going to look maybe a little weird to you, but it is totally fine. H of x equals 6 minus x. This is a fun example because we get something interesting in the end. Again, we're going to replace our function with y. So y equals 6 minus x. And then we're going to interchange the x and y. So we're going to write this as x equals 6 minus y. And then our goal is to get y alone. Well, we can subtract 6 from both sides. That gives us x minus 6 equals the opposite of y, or negative y. And then to turn that into a positive, we want to divide both sides by negative 1. When we do that on the right, that leaves y alone. And on the left, dividing by a negative changes the signs. So that positive x becomes negative x, and the negative 6 becomes positive 6. So we've got negative x plus 6. And I'm going to rearrange those terms. I'm going to write it 6 first, so that's going to be 6 minus x. And so that is our inverse function, h inverse of x equals 6 minus x. And the interesting thing that you see here is that the inverse function is actually the same as the original function, and that does not happen every time, of course. We've seen other examples where that's not the case, but there are certain functions that are their own inverses. So it is perfectly fine for that to happen in this situation. I actually want to quickly look at one more example, r of x equals x squared. Now, this is not a one-to-one function, so we can't just find the inverse the way it is. We're going to have to restrict the domain. And we're going to do that in a moment, but first I am going to write y equals x squared. And I want to talk about kind of the problem that we run into here. Because if we switch x and y, that's going to be x equals y squared. And then to solve for y, we've got a y squared. We would theoretically take the square root, because taking the square root is kind of the opposite of squaring something. But the problem is that there are two square roots of any positive number. There's the positive square root and the negative square root. And so we have to make a choice. If we take the square root of both sides, we either have to take the positive square root or the negative square root, which would be if we put a negative sign in front of each of those. And the thing with that is that this depends on how we restrict our domain. We know that y equals x squared is a parabola, and it is symmetric across the y-axis. So we either have to choose the right side of the parabola or the left side of the parabola. If we choose the right side of the parabola, that is restricting x greater than or equal to 0, that corresponds with taking the positive square root. And so in the end, we have y equals the positive square root of x. And so our inverse function is going to be just root x. But if we decided to restrict our domain to the negative numbers, then we would have negative square root of x, because if the domain of this function was the negatives, that means the range of the inverse function is the negatives, and that includes that negative sign out front. It would also include 0, but it's just easier to say the negatives in that explanation. So this is an example just to give you an idea of how we might have to restrict a domain when our function is not 1-to-1.